Hey, what's up? Shin here from Code and Quick Tips. Today with a new video on OOP versus component-based entity design. First of all, I want to talk about those two terms, OOP and component, and in what relationship this is to your game. So basically, what we are looking at here is how can you handle your game objects? How can you handle your entities in your game? There are different approaches to do that. And the OOP and the component approach are the two main approaches that you will see and the two main ways to do it actually. So I want to first talk about what both of these are, and then I want to compare both in terms of performance and how user-friendly they are for you as a game designer or game programmer. So let's start off with the OOP-based entity design. So basically, OOP stands for Object-Oriented Programming, and that's basically what you do in Java, for example, all day long. You model your game out of classes, so each game object is an actual Java object based on an actual Java class, for example. In that way, you would design component-based. To give you a little bit closer example to a real world, let's say we have a game and we somehow want to manage our entities, and we somehow want to model that in the OOP approach. What we would do is we would get one base class, as that is what OOP is all about. So let's say we got our base class, which is an entity. Here we go. So that's our base class. And that base class will have some base functions like update and render that will be called by some sort of entity manager, which has a big list of all entities in it, and it will just call this message on each entity one after another. And that's our base object or our base class. And in an OOP design way, we would now say, well, our base entity basically does nothing. So we need to extend that base entity, so we need to get subclasses of that and modify the behavior to actually get our actual game objects done. The key principle here is, as I mentioned, inheritance, which is the key principle of OOP-based design anyways. So let's have a look here. Let's say, what does every object in our game need? Well, it should be visible. So we would say, extend a new object, which is, let's say, I don't know, a visible entity. So we got a subclass here, which basically is an entity, and it's the only things that we added here is the functionality of it being rendered onto our screen. And that way we can actually now go on and say, well, what else is a special, a more specific use of our entity, and we would go on doing that. For example, I could say, well, maybe a visible entity we have set. And let's say we have items in our games, so we would say all items have common behavior, and therefore we actually create a class which is the item, which would then add some item functionality like the inventory functionality, the functionality to grab it up to our usual entity, so the user can interact with that item and can handhold it, for example. And there we would again extend the visible entity and just get a new subclass, which is the item set. And this is really a simplified way of what I do here. So here we would, for example, say, I don't know, let's see, item, I don't know, some sort of weapon. That's really just pistol, I don't know, what stuff you need in a game. We would just get subclasses here, and that way we would build up our inheritance tree. So we start off with a simple object, and we get more and more specific in the inheritance tree by extending existing objects or existing classes. So that's the basic idea. One problem, sorry for that comes to our mind here would be the following. Let's say we got items in our game, we got like, I don't know, some sort of shooter, and we got vehicles in our game. And the vehicles, you can't like grab them up like items. That's, yeah, I mean, it's a vehicle, you can enter it and drive it. So we will add those extra features to our visible entity in the vehicle subclass. And now there comes a little bit of an error that we can actually see here. So let's say we have a basic vehicle, so everything is good. And we have, I don't know, a van, which is a usual vehicle, no problem. And we add some other vehicles, no problem. We just added some stuff of the basic vehicle class, that works fine, and we balance that. But now there comes a slight problem. Let's say we got a skateboard. So you would now say, yeah, what's the problem? It's just another vehicle. We can drive it, we can enter it, we can, we can use it and drive around. But there's one big bad thing about the OP system, which you will not only find in game development, but it's specifically bad in game development. Because what is if we want a skateboard to also be an item, so we can grab it and put it in our inventory and use it? That won't work in that way. Because what you can see here is we split up the inheritance tree because we didn't thought about a skateboard also being an item, so a vehicle could also be an item. We didn't think about that in here, so we didn't actually pre-plan that we would somehow have a skateboard at some point in time. And that's a big problem here, because in OP-based design, you always go from one simple base object and you get more detailed in the inheritance tree. So you go down here and you get more and more detailed down here. And the problem is you have to know what you will create in the end to actually get that inheritance tree done, which is also true in other sorts of software development, but in game developments, it's really bad because you never really know what you will build up in terms of game mechanics in the beginning. You might know I will build up a shooter, but, well, what items, what vehicles will be there in the shooter? You can't know that. And that design approach can get really ugly for bigger projects. So that's the downside of the OP design model. As soon as your project gets bigger and you get a more complex environment and you can't plan everything ahead, this design model is really static, which is bad. So why do I still mention that? It's because most of you use it, because you're used to it in terms of a software developer or a programmer, because that's what you learn in your programming book. Go for OP system. That's what you learn in your book. And that's nice for small projects where you can plan out that whole tree first and paint it up and say, yeah, that will work and I won't have any problems there. But as soon as you go for a bigger project or anything like that, you will see a different model. And I don't know if some of you, so it's a bad thing, let's sum it up. OP, the good thing is, it's fast for small projects, it's easy to understand, and every one of you already knows how that works. That's no problem. The bad thing is, it's clunky if your project gets big. And what happens if your project gets big? Well, big game engines do that all day long, and they do it pretty good by using the component-based system, which is the second design approach to the problem on how to handle entities. So what is a component-based system? Components. Here we go. What is a component-based entity system? So before in the OP world, we said we have one base object and we take the inheritance tree. In a component-based system, we try to actually not get more complex in terms of object, and we try to basically, the big idea here is to split logic up. Not to say we build up logic and make it more complex, but to say we split the different parts of our logic apart into small little bits that we can handle, and if we sum up all the different bits you want for a specific object, all the different behaviors, then it will build up that object. So I will try to show that to you. So what is component? Basically, you got an entity object always, and that entity object will be managed by some sort of entity manager, like in the OP approach. That's nothing special. But the entity object here is really an empty object, basically, in terms of logic. So that does nothing. An entity object is just zero. It's zero, it has maybe an ID to identify it, and it gets called like not more, it just has an ID. The entity object is not more, it's just an empty object basically. So now you might ask me, hey, how do we add logic to that? And here's where the component comes in. Basically, an entity can get assigned different components that you create. Each component consists out of some game logic. For example, I can say I create a component, so we got a component base class, and I create a component called render component. So what that is basically we got a superclass, which is the component, and we can do a lot of subclasses of that component, and each of the subclasses of the component will have some specific logic programmed into it. For example, the render component will have an update message where it renders our game object. But so how do we now like add that together? Because now we got a component object and an entity object, and the entity is empty, and the component is not involved in our system. So what do? Basically, we say we assign the render component to our entity, and at that point where we add a render component to our entity will be rendered. So the render component will be called basically. So what we can do here is we can create different sorts of components. So let's say we got an item component, which will get us a pickup logic and stuff. We got a drive/car component, which will make the item drivable. We will have something basic, a health component, which will give the item a health and destroy it. If you like shoot at it, it will like explode if it takes too much damage. So we can get those little bits, and all of these are components. And now we say, I want to create an item set you can pick up and destroy. So get an empty entity, and then say the empty entity we add one item component, one health component, and we add some render component. And all those three together will make a game object that is rendered in our world, that is handled as an item, and that can be destroyed. Wow, isn't that perfect? Yeah, sure, it's perfect. Now we want to make a car. We will render the car, we will make a drivable car, and we will give it health to destroy it. Whoops, we got a car. And we just recycled a lot of the stuff we actually used for our basic item before. So what I want to say here is a component-based system is different to an OP system. You don't build up an inheritance tree, but you build different bits of your game objects. Every logical bit will be one component. For example, jump is one component. A position, one component. Render, one component. Health, one component. Then you can get more specific. You can get different stuff as components. For example, if you got a position component, and yes, let's say you got a position component, then you can apply gravity component to it, and it will automatically drag it down, or you can apply a collision component to it, and it will collide with the world. With that way, you build yourself up a big repertoire of those individual components, which are completely separate from each other and independent. And by adding the right components to one empty game object, that will get the logic and therefore gets basically the object you want. So you don't say, hey, I want to build a car object in my game, I need inheritance that, and that. You basically say, hey, I need a car object. What specific properties does that car have? And then you just add them in form of different individual components. The really good thing about that concept is you don't have to plan and preview what you want to build. And the really best thing about it is, and I love it personally, you can recycle. Once you build up a collision and physics component, you can use that on everything, on every project. No problem, it will work perfectly. And then you just add, the new side-scrolling components you need to make a side-scroller. And it works. That's how easy it is. Like, you can build up a whole player component, and by replacing the player input by an AI input component, you basically get an AI enemy instead of a player-controlled player. That's how good that system is. Also, this might be really abstract to you right now. I will do another video on an actual component-based system to use in your game, which is the Arithmetis Entity Engine, I guess. I hope I pronounced it right. But I will do a video on that, how to install it in Slick2D, and how to actually use it for a game project, how to, let's say, move and play around using those components. I will do a video on that so you can actually see what I mean with that. And there are different tastes of that component system, that's what I need to say. But in general, the idea behind components, the big idea is make individual functions, individual properties, and just assign them to one game object. And that way you can recycle them. That's a big idea behind component, and that's why I want to encourage you to use component at least at some point after maybe your first or second game, because it's way better, it's way easier, and it's used by all major engines. I don't know if you have ever used Unity, but if you wonder what's this drag up and collider, drag up and camera component, that's that component-based system. You drag up scripts to specific objects, and those scripts give specific properties to that object. And that's all about the component system, basically. It's so easy, it's so simple. It's just that splitting up. So, as mentioned, I will do a video to make this more concrete, and I really hope you understood what I want to say with the component-based system. I really hope. If you did not, then please let me know in the comments, and please have a look at the other video, because if you don't actually program it yourself, it's really an really abstract thing. But all in all, you should definitely have a look at component-based systems in whatever engine you're using, in whatever language you're using, and I will come up for one component-based system that will work in every Java game framework. Yeah, in every one, like libgdx, Slick2D, even JMonkey shouldn't be a problem. So you can use that engine then. And I really hope that video helped you a little bit, and that video helped to improve your workflow for making games. And as always, I would really like to see your feedback in the comments. And if you have enjoyed, leave me a like. If you haven't enjoyed, give me some constructive feedback down there in the comments. And as always, if you haven't already, please subscribe to my channel, as that really helps me, and as you won't miss any new videos and any upcoming tips for you.